Linear inequalities. We've already discussed linear inequalities with one variable, learn how to solve them, graph them, and write the answer in interval notation. Now we're going to work with linear inequalities with two variables. They're real similar to linear equations with two variables in that they have infinitely many solutions, so we have to graph them. And we basically graph them using the same steps as linear equations with two additional steps. First of all, we have to decide whether the line is going to be a dotted line or a solid line, and the inequality sign will tell us. If the inequality sign is less than or greater than, it's going to be a dotted line. If the inequality sign is less than or equal to or greater than or equal to, it's going to be a solid line. Then we're going to shade one side of the line or the other. So let's look at an example. Example 1, obviously a linear inequality with two variables. Even though it's an inequality, it's still in slope-intercept form, so it makes graphing it pretty easy. The y-intercept down here at -4. The slope +5, so up 5 to the right 1. But now comes the first new step. Before we actually sketch the line, we have to determine if it's going to be a dotted line or a solid line. The inequality sign is less than or equal to, so it's going to be a solid line. So we sketch the line passing through those dots. And now the next new step is we're going to shade one side of this line or the other. To determine what side gets shaded, the easiest method for that is to choose a test point, and the easiest point to use is the origin, the point 0, 0. Determine if the origin is a solution to the inequality, so if we substitute in an x equals 0 and a y equals 0, it gives us 0 is less than or equal to -4, which is obviously not true, so therefore our test point, the origin, is not a solution. So no points on this side of the line will be solutions, therefore the solutions must lie on the other side. So we shade that side, telling us that the solutions to this inequality are not only the points that fall on this solid line, they're also the points in the shaded region. Example 2, linear inequality. This one's in standard form, so just like equations, if it's not in slope-intercept form, the first thing we want to do is get it into slope-intercept form. So graphing it now, the y-intercept down here at -6, the slope -2, so we run off the graph a little bit. We could go down 2 to the right 1, or we could go up 2 to the left 1. Either way, it's going to be a dotted line in this case. The inequality sign is strictly greater than, so we show that with a dotted line passing through these points. And now we just have to determine what side of this line gets shaded. We can use the origin again, so determine if the solution determine if the origin is a solution to this inequality. If we plug it in, 0 is greater than -6, which is true. So therefore our test point, the origin, is a solution. So therefore every point on this side of the line will be a solution. So in this particular case, the solutions are just in the shaded region. The points that lie actually on the dotted line are not solutions to the inequality. We can see that if we use our y-intercept, the point here is 0, -6. If we substitute that into the inequality, it gives us -6 is greater than -6, which is not true. So the difference between a dotted line and a solid line are whether the solutions that lie on the line are also solutions to the inequality. A solid line means that the points that lie on the line are solutions to the inequality in addition to the shaded region. A dotted line, only the points in the shaded region are solutions to the inequality. One more quick example I want to point out. For instance, y is greater than 2x. If you sketch that line, in this case the line goes through the origin, which means you cannot use the origin as a test point. Your test point to determine what side gets shaded cannot be on the line. So if that's the case, you simply choose another line, another point that the line does not pass through. Maybe like the point 1, 0 or the point 1, -1, and you use it the same way. If your test point is a solution, you shade that side. If the test point is not a solution, you shade the opposite side.